at the same temperature. So it's going to have the same volume because it's still the same tank. And they're asking how many kilograms of this helium is needed to produce a certain pressure. So we are changing the pressure and we are changing the molecular weight of the gas, but we are keeping the temperature constant, and we are also keeping the volume constant. So let me again stop this so you can see full screen. Let me erase this. So there is one trick in this problem that they're talking about gauge pressure, and you need to know what gauge pressure is. So if you don't know what gauge pressure is, then of course you might just go on the wrong path. So that's one pitfall you might fall into. So here we have the oxygen. So the molecular weight of oxygen is 32 grams, right? Or grams per mole, if you will. Then we are going to have the helium, and for helium it's just an atomic gas, so it's just 4 grams per mole. And we start with initial mass of 30 kilograms of oxygen with some volume, and it has a pressure P0. So they say 8.2 gauge pressure, and we're going to assume that this is in 1 atmosphere ambient pressure. So this is going to be 9.2 atmospheres, or 9.20 atmospheres. And then this comes to 7 atmosphere gauge pressure, and that would correspond to 8 atmospheres. All right, and they're asking about M final. How much helium should we put in? So this is oxygen, O2, this is helium. Okay. I hope I got the numbers right. So oxygen has 8 protons with 8 neutrons, that's 16, 2 oxygen, yeah, I think it's 32. Okay, so how do we go about this? Well, perhaps the easiest is to calculate the number of moles of the initial gas or oxygen, and then calculate the number of moles of our final gas, and then from that just move on to the mass of the final gas, right? So for that we're going to use the ideal gas law, PV equals nRT, and so the pressure is changing by some amount that would lead to, so our volume is the same, our temperature is the same, the only thing that's changing is pressure. That will change the N. So I can actually write this twice and divide side by side. I would get N final is N, let's call this N0, we called everything 0 over here, is going to be equal to, so N is proportional to this, so P final divided by P0, right? So if you write this twice for the initial values and the final values and then divide them side by side, you're going to get that the M final is proportional to P final and multiplied by N0 by P naught. Okay, but what is N0? N0 is just going to be 0 divided by capital M0, right? And M final is going to be M final divided by capital M final. So I can put those in as well. So M final by final is going to be M0 by capital M0, P final by P0, and I can rearrange this. What I'm looking for is M final, small m final. So M final is going to be M0, capital M final divided by M0, P final divided by P0. Okay. So does this make sense? First of all, this looks like our final mass that we need to put in to get this pressure is proportional to our initial mass, which kind of makes sense, right? So if you have more mass initially, that will correspond to a larger container, and to fill that larger container, you will need more mass, right? Same deal here. So it seems to be proportional to P final and inversely proportional to P0. So if initially the pressure was very low, of course you will need to make up for this by having less gas. And finally, if you want a lot of pressure, you provide this by providing a lot of gas. So that proportionality also makes sense. And the same thing here, right? It's proportional to molecular weight of our... does that make sense, actually? It's proportional to the molecular weight of our final gas. And yeah, so the important thing that provides pressure is not the individual properties of the molecules, but the number of molecules. And if your final molecular weight is larger, for the same number of molecules, you're going to get a larger total mass. And by similar argument, if you had initially a large molecular weight, then this will provide a fewer number of molecules. And again, there should be some proportionality between the number of molecules, so that should be inversely proportional to the initial molecular mass. So everything makes sense, and we can put everything in and get our answer, right? So this is 30, this is 4, this is 32, this is 8, and this is 9.2. I'm not going to do this, but you can just plug numbers in and get your answer out. All right, so this is just some manipulation of the numbers, and you just need to know what you're doing with the ideal gas law. So is this clear what I did here? Have any